everybody. Thank you for coming to my talk. We were just chatting with the other speakers. You're always like, oh, am I going to be speaking to the wall all alone? So I appreciate you being here. Hi, I'm Veliswa Boya. I work at AWS. I am a developer advocate. I work with the sub-Saharan Africa community of AWS developers. I'm based here in Joburg. So I spoke on Tuesday for the first time in Cape Town. So today I'm at home. Feels really great. So I'm going to talk about how you can build resilient and well-architected apps with chaos engineering. Before I start, I'd like to ask, is anyone here already running experiments on dev, test? Anyone experimenting with chaos engineering? Okay, great. Hi, okay. So a bit about me. I already did an introduction. I like to connect. Please connect with me. That's the QR codes to reach me either on LinkedIn or Twitter. And we can just connect there. And usually after I talk, I'd like to continue a conversation. So maybe Twitter, if we connect, you can just let me know what you thought, or if there's anything you'd like to hear more about. Just give you a second. So when I put up this, I did not change the meme for today. I'm like, I still don't get memes right, so I'm not going to touch a thing. When I put this up on Tuesday, I said, I'm not sure if this is actually communicating what I mean to communicate. What this is trying to say is, I used to work in production support. I used to always work with production outages. And there was a point in my life where I felt like all the other kids were having fun while I was stuck fixing outages. So that's me being Mr. Squid, or the other kids, is it working? Did it? Oh, great. I'm terrible with memes. Thank you so much. Oh, yeah, it is, right? Yeah. So there is this saying by Werner Wochels, who is the CTO at Amazon. He likes to say failures are a given, and everything will eventually fail over time. And this saying comes from the fact that production systems are quite complex. You never know where something is going to break, and how many things are going to break, and at what point are they going to break. With this in mind, then, we say, how about we start to consider embracing failure and try to find ways to bring resilience into our applications. So before I talk about this, let me quickly catch up on what is resilience. When I talk about building resilience into your application, it is making sure that you ensure that your applications can bounce back when there's an outage. So how long does it take for your applications to actually bounce back and recover? Then we talk about chaos engineering, because it's part of why we are here today, and we're going to talk about how chaos engineering can actually help you bring resiliency into your applications. And what is chaos engineering? Not so commonly known, another word for it is resiliency engineering, and it's exactly because that's what it does. Chaos engineering was first brought as a concept by Jesse Robbins. He worked for Amazon a long time ago. He had been a firefighter before, and they used to do these game days to prepare for when there is an actual fire. So when he worked at Amazon, he thought, how about we do the same thing for the Amazon.com application? And that's where it actually started. Netflix took it to next level, of course, when they moved their applications to AWS Cloud, and they Chaos Monkey, and which they deployed on AWS to do chaos on their applications. So that is chaos engineering, and what it does is you inject faults into your application, you then observe what happens, and after you've observed, you then can act on that. So you do a measurement, you measure, and then you can just iterate or improve based on what you actually saw. So you're improving your application based on what you saw after you injected faults into your application. So that's chaos engineering. And there is this other saying by, if you do that QR code, you will get that link where you can actually do quite a read-up. This is a very interesting blog if you go and read this. This was written by Jacob Gabrielson. At the time, he was a senior principal engineer at Amazon as well. And now he was talking about distributed applications or distributed systems. He said, the moment we installed the second server, we knew we had a distributed application. So while it was just one, we were fine. And then we introduced the second one. And with that, we introduced complexity into our application. So if you check that out, it's quite a nice read-up as well. This is showing distributed systems. When I gave the talk in Cape Town, someone said, how did you do that animation? I said, I did this in 2019, I don't remember. So, but this shows, please don't ask, I'll have to go and really check it out again if anyone needs. So this is just illustrating the fact that distributed systems are complex. You have your client, and there's a network, and then you've got your server there in the back end. And from your client, you send messages via the network, gets to the server, you get a response back. Anything can break at any point here. And that's what this is illustrating, that distributed systems are actually quite complex. So we used to rely, or maybe we even still rely on traditional testing, but we found that traditional testing isn't really enough. And why is this? It's because commonly with traditional testing, you are testing for something that you know already, right? You will either be doing unit testing of your components, you're checking that the component on its own is actually doing what it's supposed to do. Or you do functional testing where you're bringing or integrating the components and you just want to check if, as an integration, are they actually doing what you actually want them to do? But you are testing and verifying for something that you know. How about those surprises that will jump at you when you are in production one day? And this is where chaos engineering actually comes in, because it brings in those surprises for you before you actually hit production and prepares you for those things that are not the known. It helps you stress your application, you observe, and then you can improve based on what you actually observed. So it helps you improve resilience and performance of your application. You get to uncover hidden issues, which is what I'm saying, like you don't know the unknown, and it helps you uncover that. And it can help you expose blind spots. So it helps you ask yourself, do I need to monitor more? Is there more observability that I need to bring in? And do I need to do more alarming? It can actually uncover all of those concepts. So this would be the process that you would follow when you are doing chaos engineering. If you go into this QR, you're going to get that doc, and you can read a lot more about how to get started with chaos engineering and the entire process. We even have templates for you that if you follow through, you'll find those templates on how to actually get started. I've got the slides as well, you're going to see. So I've already said to successfully carry out chaos engineering, you need to follow this formalized process. And how you would start with this, before you even go into this cycle, you would need to do two things. The first thing is there anyone here who's an architect before I say this? I can say it because I was an architect, so I'm not really being offensive. I was going to say, you need to first understand your architecture of your application. And I was going to say, how many of those application architectures are usually actually up to date? I know when I was a solution architect, we built and then we draw afterwards. So, but now you need to actually understand it has to be accurate, because you need to know the components that make up your application so that you know where to actually inject your faults as you do chaos engineering. So where would you start? You would start here. You need to understand the steady state of your application. So what does ideal actually look like? And this you actually would do in conjunction with your business. Because when you are doing chaos engineering, you're not just disrupting the application, you're disrupting the business as well. So you work together with them. So you define what does a steady state look like. Customer experience, what does that look like? And once you've defined that, now you're going to go into defining your chaos engineering process. You're going to define a hypothesis. So a hypothesis, you're saying, if I bring down 2 instances, I'm going to affect performance by 20%. That's the hypothesis. And then you will start to run your experiment, because you've defined all of that. Now you start to run. And here, by verifying, you are doing the observation that I mentioned before. And out of that, you can improve and iterate. And the improving and iterating, you're improving and iterating on your application, because what your chaos engineering is trying to do is that even when some instances are down, I should still be able to serve my customer. Customer experience should not be impacted. So based on what you're seeing, you're improving on your application. So why has it been a challenge for people to actually get going with chaos engineering? This is a back and forth discussion we have with some of my teammates, especially those of us who are actually focusing on chaos engineering. It's, are people doing it? I was saying to my one colleague, it looks like it's a niche thing, and it shouldn't really be a niche thing. It should be what people are actually doing on their applications. But there are challenges with getting started with it, and why? And this is because traditionally, it's been tough to get started with it. There weren't always tools for you to actually do it. And you would have to build these tools together. Last night, I was looking at one of the tools that my teammate actually built, and I thought, there's no way. I mean, who would actually approve you running with that? So I get why organizations would be doubtful sometimes. And it's because you had to stitch together different tools and homemade scripts to actually get started. And after you've done that, or while you're doing that, you maybe need some agents and libraries, and you need to find these or build them. And then it's difficult, after you've done all of that, it's difficult for you to ensure that what you're doing is actually safe. And how are you going to be sure that you are reproducing real-world events? And by this, I mean the fact that when things break in production, normally it's not just one thing that's breaking. And an ideal chaos engineering experiment should take that into consideration. You're not just bringing down one instance. It could be that, and other things are actually also breaking. So it's those real-world events. How do you make sure you reproduce them? But there are tools that you can actually consider for this. And I know I work for AWS, but I'm going to talk about other tools as well. Just talk about them and then keep on moving. So there are some popular ones that are out there. There's a lot more that you can actually find. One of the more popular one, it's open source, Chaos Mesh. This is for injecting chaos into your Kubernetes clusters. It's open source, so you can actually get going with it without needing a commercial license. So it's another tool you can actually look into. There's the famous Chaos Monkey. Chaos Monkey was actually built by Netflix developers, and it's also open source. And how Netflix actually does their deployment on AWS, they always make sure it's across 3 availability zones, and those are 3 data centers in a way. And when they run chaos, they just make sure one of those AZs they bring down, or 2, and actually see how the application is going to respond. So there's that as well. You could actually maybe just try and play around with. Then there's Gremlin. Gremlin is not open source, it's managed. It's the first managed SaaS, software as a service, chaos engineering tool. What's great with this is that it's got a very user-friendly way of you interacting with it. You just define parameters on a console, and then that's how you can actually get started with your chaos engineering. And then I was shocked that this one that I'm going to mention now, people do not know about it. How do you not know about AWS Fault Injection Simulator? This we launched in at reInvent of 2020. It's an AWS Chaos Engineering managed service. So it's for you to inject faults into your AWS applications. What's great with it and what drew me to it is the fact that I like the concept of you define an experiment template, and you define that once, and that can be used multiple times when you now actually go and run your experiments. And what's great with that is that it's one template, and your team can actually share a template. So one person creates templates, and then it can be reused. So that's what I think is great about it. And I'm going to do a demo. So I've already touched on this. So when you set up fault injection simulator to get started with it, this would be the process that you would follow. And the demo that we're going to look at is actually following this architecture design. So this is where you are. you've got your AWS fault injection simulator here. And on it, you are creating or defining your experiment templates. To do that, you can either do that on the management console, which is nice and quick to get going with, or you do it on the CLI, AWS CLI. You can define your template. So that's where you're defining your template. But once you've done that, all the running of the experiments is on the console on AWS. So when you define your templates, you need a role, and that's defined on AWS Identity and Access Management, and the role has to have permissions to do whatever it is that you're saying your experiment must do. So if your experiment is stopping instances and starting them, the role that you've defined, when I look at all of this, has permissions to do that. So once you have all of that, you can then run your experiment. And services that we right now have where you can run experiment against are compute services. We've got EC2 instances, which is our VM on AWS, ECS, our containers, EKS, and we've got database services as well, which is our relational database service right now that you can run an experiment against. We've got networking, and then we've got storage services as well that you can run against. And then there's a thing called safeguards. Safeguards is to safeguard you. As you're running your experiment, something to say, oh, maybe you shouldn't. And we have Amazon Event Bridge, and here you can define events. I've actually got an event that we can look at when we run the experiment. So the event that I have, every time the status of the experiment changes, it sends me a notification. So that's how you could safeguard yourself as well. Or you have an alarm on Amazon CloudWatch. Monitoring right now, you can do with third-party tools. We don't currently have much monitoring that you can do on AWS. The service is fairly new since 2020, and we're still gathering a lot of feedback from customers on what we actually need to build for them. Okay, those are all the links that I was mentioning, and I'm going to go into the console after I'm finished with the slides, and we're going to actually look at the demo. I have a speaker deck for you. If you access that, you'll be able to look at all these links that I was sharing, and that's how you can access these slides as well. Oh, you still, must I go back? And thank you so much. That's the survey. Please, I appreciate feedback. Just let me know what I could have done better. And thank you. I will now move on to my console, and we will start looking at the demos. And as soon as you see my console, you're going to see something that is not good practice. You're going to see my account number, and it should not be showing. But I will kill this account after I'm done. I do work for AWS. I can get as many accounts as I want. Can I really? But yeah, but you shouldn't be doing this. But yeah, so I'm now going to switch from here onto. Yeah. So I talked about, okay, first let me go on to, not seeing anything right now. Oh, okay.
So just drag it over to your other desktop.
Okay.
You're on extended display.
Okay, thanks so much.
Drag the whole like there and just drag it over to the other screen. There we go.
Okay. Okay, sure. Thank you so much. Should I just zoom in a little bit? Can you see? Is it too big? Is it fine? Okay. So the first thing I'm going to show you is a console where you're going to see the templates. I'm going to have to keep hopping back and forth because I can't see from here over there. So I talked about creating templates first, and then after that, from those templates, you can actually run your experiments. And I've got templates already that we can actually look at. So that flow that I was talking through, the templates, the role, I already have all of those, but we're going to go and drill in and look at them. And this is where you would actually define your template here or on the CLI. I have a template that I created. Let me just go into it. This one. What this one will do is that it will stop. It's got actions. Within a template, you define an action. So what you want it to do is stop an instance. And then target. That's where you would define what instances you're actually stopping. And so I have here that stop it for 1 minute. And then targets, let's go look at the targets. And I've defined an instance using a resource ID. And that is the resource ID of the instance that I'm actually stopping. And then let's go look at my EC2, because that's where I've got all the VMs that I'm actually going to be stopping today. So I've got 5 that are running. And I'm just going to pick at random and just inject false, stop them, and then they're going to start again. And then I mentioned about the role that I need to have has to have the permissions to do what we're trying to do. Okay, so that's where you would define your roles, your users, your policies. Policies you attach to your roles and users, and you use your policies to define permissions. And I've got a role here. And I've got 2 roles. This one does not have the permissions. This one does. And that's the role that I've actually attached to that template when I created it. Let's just look quickly and see what permissions we have. Okay, so I mentioned that if you're stopping instances, it should have permissions to do all of that. See, those are all the actions that it's actually allowed to do. Can reboot, stop, start, or terminate an instance. So that's what your role would actually have as permissions for what you are trying to do. So we've looked at the template, we've looked at the instances where we're going to pick one and stop, and then we've looked at the role and what that looks like. And I have an event on EventBridge. I've defined a rule that every time there is a change to state of my experiment, it must send me a notification. Before we had EventBridge, we used to define events on CloudWatch, and we are now moving away from that to EventBridge. And because the whole idea behind that is the fact that EventBridge can actually integrate with SaaS tools as well, not just AWS services. And that's what's great about it. So, and now let's look at the rule that I have that's going to send me notifications. And after we look at this, I am going to start the experiment, and I'm going to switch on my phone's notifications because I should be getting SMSs when this starts to run. Okay, so I already have it. I don't want to edit it, so what's the best way? I have it here. Okay, let's check next. Okay, I'm trying to not edit it. Okay, let's start. We can come back and look at this afterwards. But let's start the experiment so that we can actually start to see this in action. Okay, I've got a template, and I'm picking the one that's just stopping an instance by resource ID, means by the ID of the actual, so it's targeting an actual instance. And I'm going to start the experiment. So state has already started to change, and if we go and look at the instances, there will be one that is stopping soon. And I better be getting notifications, else this is not working. So I have my cell number subscribed to a topic to get notifications, and I've got an email. So the first state change has happened already. It's gone from initial state to initiating. So it is actually running already. And there should be an instance here that is stopping. Yeah, that is stopped there. Okay, so every time the state changes, I'm getting a notification. And I'm going to show you on email as well, because that's where you'll be able to read there. I've got a burner account here that's also subscribed to the same topic. Those have started to come in. I've not cleaned it up yet. There's another service you could plug in if you want to actually clean up your notifications, but this is just quickly for this demo. So that's what it would look like. And now we're going to back here. So now let's see what the next state is. So it went from running to completed. If we go back onto the console, let's see if it's now actually completed. Okay. Let's check that date. It's at the time now, yeah. So it's just completed. So that is the demo. I don't know if there's any questions on this. You can just let me know. So this just sums up or starts to introduce how you can actually start with running experiments. And there's ways that you can actually safeguard yourself by having events that send you notifications. And you can actually, the other question I had in Cape Town is, how do I get my CIOs buy-in into this? So notifications, you keep them in the loop as you actually run these experiments. And the fact that you're starting small, you're not starting on production, you start in dev, and you're defining your blast radius as you do that by making sure that it's very small components that you're actually working with. And as you earn trust and gain trust, you start to go bigger than that. You're not starting in production, and you're having those safeguards in there for you. And that is that. That's how you can actually get started. Are there any questions?
Can you have the events published to CloudWatch anyway?
I would say yes. And I think it integrates with Slack as well. Yes, yeah, you can. Yes, thanks.
Hi. With regards to chaos testing, what more can you test? For an example, let me say we have a stream of data coming through Kafka, for an example. Is it possible to also do chaos engineering within this platform to test it? Maybe let's say, for example, topics are down, or the feed is down itself, or the feed itself is down, or is it just focused on the infrastructure side of things?
Right now, it's mainly the infrastructure services that we have, our EC2s and our container services. But you can build in pipelines, because I know you can actually have this in a pipeline where you have an AWS Lambda actually invokes it. So that's now how you'll start to build, to bring it into a pipeline. I've got a blog that I can actually share that actually starts to introduce how you can actually do chaos engineering in a pipe as part of a pipeline on AWS. I think it's actually, when you go into my slides, I think it actually is there.
All right.
Yes.
Yeah, thank you. My question was going to be, I know you mentioned that typically you would implement chaos engineering pre-production, but sort of how far left in terms of the software development lifecycle can you actually, or should you be thinking about chaos engineering?
As you're developing already, we say you start in dev, and then as you go through your stages, you can actually, you're already introducing it there. And the other question that also actually gets asked is, when we are implementing projects, there's a budget and there's a timeline. How do I actually justify this as being part of that project? And that's why, as far left as possible, then you just bring it in there already. So as you're doing your development and then you move through the stages, you already have it as part of it. Oh, okay, I'll do that. Thank you.
Hi, just a quick one. So you've shown, obviously, in your demo that you've been able to switch off one of your instances based on your template you've defined. But how would you go about actually validating what the impact of that shutdown has been on your entire estate? Obviously, to understand, like, you switched an instance down, but has it resulted in an outage or not?
Okay. So how would you actually measure that experiment that you actually ran? So in a typical production environment or a real life setup, that instance would not be standalone like it is now. You'd probably be part of an auto-scaling group, and there you can actually, your auto-scaling group actually will do the reporting for you, and on CloudWatch, those alarms would actually do the reporting for you on the impact to your systems. So that's how you would measure. This demo that I did was very simplified, and it's not really real life.
So I was just wondering, obviously with AWS Fault Injection Simulator, it's an AWS specific tool. Of the tools you mentioned today, are there any cloud agnostic ones?
I would, so are there any chaos engineering tools that are cloud agnostic, that are not in, the ones that I mentioned today are all in the cloud, and a lot of them are cloud native.
I guess what I would say is, are there some of them that would like work on DigitalOcean and Linode as well as Azure and AWS?
I can't say for sure. Of the ones that I mentioned today, I can't say for sure. Does anyone have sounds like someone is whispering a solution? Oh, you don't know, okay. I can't say for sure, so I'd have to look that up. Okay.
You mentioned that the solution is kind of better than the old way of testing by the test because we validate things that we don't know. But here, really, the factor is not so much unknown. If beforehand we control the fault, wouldn't be advantages for the solution to offer a portal where issues or faults cannot be only controlled by you, and then we validate that unknown factor that you mentioned.
Okay, so you're saying that from what you're seeing here, you're already defining what you actually want to chaos, kind of, and you want to go beyond that.
To validate that unknown that is the basis of the solution, it should offer means of having defaults flowing into
Okay.
the applicant that are not only controlled by you. Then we can validate this is really unknown.
Okay, so I think, so you want to make sure that you're really validating an unknown. I think it goes back to that cycle that I was talking about when you're defining a hypothesis. So I think it's not really possible to never, ever have complete surprises. What you can actually start to have with this is because you can include your chaos engineering experiments as part of your pipelines, that's how you can actually start to introduce those surprise elements into it, because you can do scheduling behind that as well, and those come out of nowhere. You can randomize the chaos that's going to be introduced into your application. So that element is it. But I think complete surprises, I don't really believe you can actually really have, because right at the start, you define the hypothesis, and there's some element of what you actually know. So when you're going to start, you have an idea of what you want to bring in as chaos onto your application.
Maybe kind of related to that is, do the templates include like common patterns that you're already familiar with? So, like, or what is the most likely thing that could happen? Like region disappears, or VPC, like these are the kind of problems we've seen in the past in similar setups as you have.
Mm-hmm.
And here are some tests that you can run against that.
Yes, and it does tie back to that and what I was saying before. So you're saying, could you have some predefined faults that you kind of have an idea because they are your usual occurring ones, and that's what you actually introduce as chaos. And that is that exactly. And it's behind why, when we did with fault injection simulator, we started with bringing down your instances, because that's normally the more commonly occurring ones. And that's why we've got injection faults you can inject into your containers, because that's commonly what happens. Your API throttling, we've got that as well, because those are your common faults. So you start there.
What kind of database faults can you inject?
So this would be across your, so what database faults can you actually inject? You would have your, this is on your relational database, because you would have it highly available, so you can bring down one of the instances. You can start there. That's one of those that you can actually inject.
Does it support injecting faults into your network configuration environment, like your DNS resolution?
Does it
Your network configuration faults can you inject, like DNS configuration, DNS resolution, things like that?
Okay, so what network faults can you actually introduce? I can't say offhand. I would have to look into those. Okay.
A common model that we often use internally is load injection, so load simulation. So we often generate artificial load on our systems. Is there a public-facing model or tool that customers can use to do something similar? So, because a large portion of failure risk in AWS is often related to gentle degradation or partial degradation due to overload. And we test that extensively. So can customers also generate artificial traffic? Is there tools that they can use for that?
There are two. So can customers generate load onto their applications and then test against that? There is no AWS tool that you can use right now to actually generate load, but I know there are some third-party tools that you can actually use to generate load onto your applications. Okay, is that it for questions?
So there was just one question in Slack. You said share your slides in Slack afterwards.
Okay, I will share my slides on Slack as well, over and above the scan that I had for the QR code. Okay, thank you very much. I think that's the end. Thank you.